We're starting our basic geometrical reasoning. This is thinking about geometry. The word geo is a Greek word. It means the earth or land, and metry is measurement. So this gives you an idea about the origins of this science called geometry. It was about measuring land, especially so you could sell it. You knew how much land you owned, etc. To start off with, something very, very simple is a line. Now, if we have a line, let's draw one here. There it is. We call this line a straight line when every single part of it lies in the same direction. So it's a straight line where every part of a line is in the same direction. And that's a line which is called straight. So what I want you to do now is this. I want you to make 2 points on your page. Here's one. Here's another. And remember, a point, which we'll call a point like this, is an imaginary dot. Yes, I've drawn it here, but in reality, in geometry, the dot doesn't exist. It's only an idea in your head. And we connect the 2 points with a straight line. You must use a ruler at all times when you're doing geometry. You use a pencil, not a pen. Make sure it's sharp. Right? I've sharpened a few pencils here in advance. It's very important before you begin to sharpen your pencils. And we draw a line. Notice how I'm holding the pencil between the 2 points, like so. And this is a straight line between 2 points. The shortest distance between 2 points is always going to be a straight line. Now, a line which has got no straight parts is called a curve. So, to draw a curve, you can either use your set of compasses. Here they are. To use a set of compasses, what you do is you take your pencil, you put it in like this until these 2 points here are matching. It's important that your pencil is sharp. You tighten the pencil in place. Now, to draw your circle, you put the metal part of the compass into the paper so it makes a hole. Right? And then you use the little bit on top of the compass, so I call the twiddly bit, and you can twiddle the compass around like that. You don't use much force, just very lightly. Let the pencil sit on the paper, and you can draw your curve. Here we have a curve. Okay? Lean it into the direction that you are drawing. Okay? Don't push the compass that way. If you do, it'll end up moving. Also, make sure that your compass is reasonably firm, that the screws at the top, if you have screws, are tightened. If it's loose, the compass will drift. So this is a curve line. You can also make a curve line with a special kind of ruler, which is a bendy ruler like this one, and you can make your curve line like so. Right? So a curve line is a line where no part of a line is straight. What I want you to do now is press the pause button and do the following. Firstly, make 2 points on your page and connect them with a straight line. I'm going to ring the bell so you can press the pause button. The next thing you need to do is draw 3 curved lines. So use your set of compasses or some other means. Another way of doing a curved line is to take your ruler and bend it like so. This requires 2 people usually, or you have to push the ruler against something and you can get a curved line using your ruler. So when I ring the bell, press pause and draw 3 different curved lines. Now, if a straight line can lie flat on a surface, so here's the ruler, it's got a surface. Okay, if I can take a line and put the line flat onto the surface, I'm going to do that now. Whoops. So here's the edge of this ruler is a line. We bring it on, and I bring the line down, and you can see the line is touching the surface in all places. Right, so here, this line, right, I can do it to the paper as well. I can bring the line down, that's the line, the imaginary line on the edge of this here, and it's touching the surface here. It's touching it at all points along here, and so that tells us that this surface here is flat. Right? If the line on the edge of this didn't touch this surface at all points, this surface would not be flat. For example, let's take a surface that's not flat. Here, right? This is not flat. If I put the line down onto it, it's not touching it on all of the surface, and therefore this surface is not flat. Right? I can do the same with something else. For example, here's a surface that's not flat. If I put the line down onto it, there are bumps. There's one bump here where the button is, another bump here, bump, 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 bump. And so this surface is not flat. Right? There are spaces between the line and the surface. Now, a perfectly flat surface, which cannot exist in the real world, a perfectly flat surface is called a geometrical plane. A geometrical plane. This is a perfectly flat surface. So, if we could imagine such a thing, because in reality everything's made out of atoms, and atoms of course are bumpy and round. So even if you put atoms to make the flattest surface you could imagine, that flattest surface would not be flat. Right? It would have bumps, little bumps of atoms. So there is no such thing in the universe that we live on which is actually flat or smooth. That's why all of these things, straight lines, curves, they only exist in your imagination. When we draw a curve, it's like we're drawing a map of a curve. Just like if you look at a map of the area you live in, the lines on the map aren't the actual streets. Just like this curve that we draw here, or this straight line, isn't an actual line. It's just a map of the imaginary line. And we draw a dot for a point, well, that isn't the point. The point doesn't have any size. Right? If it did have size, it would be a little circle. So, if a straight line can lie flat on a surface on top of it, touching it in all places, then the surface is flat. Right? If we could actually do that. And a perfectly flat surface, which only exists in the imagination, is called a geometrical plane. So, if no part of a surface is a geometrical plane, then it's a curved surface. So, if we take this, for example, right, no part of this is a geometrical plane, so the surface is curved. Whereas, if this were perfectly flat, then it would be a geometrical plane, because all parts of this surface are flat, and I could lay a straight line down on the surface and it would touch the surface at every single point. So I'm going to ask some questions now, and I'm going to ring the bell, and I want you to note whether the question is true or false. Right. So I'm going to draw a line. Here it is. Now, this line lies on a surface, and it lies entirely on the surface in all parts. This surface is a geometrical plane. Is that true? Or is it false? Is it true or is it false? So I want to draw this line in your book and put the T and the F next to it, and then circle which one you think is correct. That this line lies on a surface, and it lies entirely on the surface. This surface is a geometrical plane. Is this true or false? Now I'm going to draw another line. Here it is. Right? There's our other line. This line is touching a surface, so we can imagine there's a surface here, right, underneath it. There it is, there's the surface, right? The line is touching the surface. Just like this line here is touching the surface. So the question is this surface here, where this line is touching, is it a geometrical plane? And is that right? So if I was to say this surface here is a geometrical plane, is that true or is that false? Is this surface a geometrical plane? The line is touching the surface. Now, a planar surface, let's write that out for you. Planar surface. That means a surface which is flat, like a piece of paper, but of course even flatter. And it has edges, which can be drawn with lines. So let's imagine, here's a flat, this paper's flat, right? Let's put some edges. Here's one edge. I'm making some lines here. 2 edges, 3 edges, 4 edges, right? 5 edges. So we have a flat surface here, and I've enclosed it with edges, which are straight lines in this case. And this is called a geometrical shape. We see it here. Geometrical shape. It's also called a geometrical figure. This comes from the Latin word for shape. And we'll see that there's lots of Latin or Greek going on here. So it's a geometrical shape or a geometrical figure. Now we need at least 3 sides to do this, because if I do one side here and one side here, right, I don't have a figure. Right? To enclose it, I need at least a minimum of 3 lines. Okay? If I put a line here and a line here, I don't have a figure, it's not closed in. And if I do this, a line here, whoops, a line here, and another line here, I also don't have a figure, right? Because it's not closed in. I can only get a figure if I enclose it completely. For example, here, and now I have a figure, and here I can close it up, and I now have a geometrical figure. So what I'm going to do now is draw a number of things, and I'm going to ask you whether or not they are geometrical figures. Let's start. Firstly, this. Is this a geometrical figure? True or false? Right, is this a geometrical figure? True or false? Right, these three lines do close around a shape or figure, and there are three lines. If I say this is a geometrical figure, is this true or is it false? Right, these two lines do not close around the shape with an edge. There are only two lines. They form a geometrical figure. Is that true or is that false? So is the statement, these two lines form a geometrical figure, true or false? Right, these three lines do close around a shape with an edge. There are three lines, 1, 2, 3. They form a geometrical figure. Is that true or is that false? Right, these two lines they do not close around the shape with an edge. There are only two lines. They form a geometrical figure. Is this true or is this false? Now, a bit of Greek. The word gon, let's write it out for you. G-O-N. This is a Greek word, gon, and the word gon means an angle or a corner. So it means an angle, here's an angle, or it means a corner. Right? Here's, for example, here's a house. Right, there's a house, not a very good one. I wouldn't want to live in it. Right, there's a house, and this here is a corner, so it's called a gon in Greek. Tri is also Greek, and tri means three. 1, 2, 3. That's what tri means. And this gives us two words. We have the word trigon. A trigon is something with three angles. For example, 1 angle, 2, 3 angles. And in Latin, this is the Greek word, trigon. In Latin, we call it a triangle, right? 3 angle. The word angle and gon are the same thing. This one is from the Latin, right? And this is the Greek. So they're exactly the same thing. Trigon, triangle. The word poly, another word, this is also a Greek word. Poly means lots or many. And so a shape that has lots of corners is called a polygon. Gon means angle, so here's a polygon. For example, this one here, lots of corners, right? 1, 2, 3, 4, 5, 6, 7, 8, lots of corners. So it's a polygon. And we call it, very simply, a polygon. So anything with more than the minimum of gons to make a shape is a polygon. And of course, what is the minimum we require to make a shape? Let's show you again. 1, 2, 3. Right, we have to have 3 lines. And this is a trigon or triangle. Anything with more than 3, right? Here's 1 corner, 2 corners, 3 corners. So 1 gon, 2 gon, 3 gons. If it's got more than 3, it's a polygon. And there are different kinds of polygon, and they have special names, which we're going to be learning. Right, let's go on with the words we need. Now, we have some Latin words we need. One word that we need is the word for side. Right, here's a person. Let's draw him, or her, as the case may be. Right, there he is. Right. And he has 2 sides. Here's one side, and here's the other side. Now, the word for side in Latin is latera. And we have to know this because, for example, this here, we've looked at how many gons it's got, but it also has latera, right? So here's one side. Here's the other side. And here's the other side. It has 3 sides. And so we say it is tri, which is our word for 3, we've seen already, lateral. So a trilateral is the same thing as a trigon or a triangle. Right? If we say a trigon, we're talking about the angles. A triangle, same thing, but in Latin, and trigon is in Greek. Trilateral, we're talking about the sides. So every trilateral is also a triangle. Then we have another word. And this word is a Latin word, quad. Quadri, which means with 4. So quadri means with 4. We already have lateral, telling us it's got sides, and we have tri, meaning with 3. So tri is with 3. Let's write down tri here, and that's with 3. Quadri is with 4. So a quadrilateral is going to have 4 sides. So let's draw one. 1, 2, 3, 4. That is a quadrilateral. And let's draw a trilateral, just so you remember. There it is, a trilateral. Which has got 3 sides. Trilateral. So, some questions. Does the word gon mean a side? Is that true or false? Does a triagonal geometric figure have 4 sides? So does a triagonal figure have 3 sides or 4 sides? Does poly mean many? Is it true that a polygon only has got two corners. Is the word for the side of something a gon? Is it true that a trilateral geometric figure has got four sides? Is that true or not? And is it true that the word quadric means with three? Is that true or false? Okay, and that's those are the questions. So, gon, does it mean side? A trigonal figure, does it have four sides? Does poly mean many? Does a polygon only have two corners? Is the word for the side of something a gon? This word here, trilateral. A trilateral geometric figure, has it got four sides or three? And a quadric shape, has it got three or four of whatever it is? Right, let's move on to the next part of our geometry lesson. Let's get a new sheet of paper. Now remember that when two straight lines touch, here's one straight line. When I get another straight line and it touches another line, there they are, they're touching, then it forms an angle or a gon, right? So this is here, this is forming this thing here where the two lines touch is a gon, also known as an angle. If I were to draw a triangle, let's draw one here. Nice big triangle. It's not a very good one. Well, I suppose it's okay. Then the top of the triangle, here's the top of the triangle, up here. Right? This is called, in Latin, the vertex. Right? And this is the summit or the top of the triangle. So the pointy bit, the vertex. So in Latin, this means the top or the summit of the triangle, the vertex. Now, what I'm going to do is I'm going to ask you to draw a triangle and to circle its vertex. So draw yourself a triangle and circle its vertex, just like I've done here. So make a triangle of any type you like. For example, this one. And in your book, copy this. Find the vertex, which is the top of the triangle, and circle it. And I want you to label it vertex. Now, any angle we like, no matter how big or how small, right? No matter which direction it's going, whether it's going this way or whether it is going that way, it makes no difference how we do the angle. Any angle, we say that it has some parts. It has legs, right? And it has a vertex. The way that this language came about, of course, came from the ancient Greeks imagining, here's a little man, and here are his legs. Here are his legs, right? So he's got legs. Leg. And he has another leg here. And this point here where the two legs meet, this here is the vertex. And even if he used to do a headstand, there he is, right? He's doing a headstand. There's his head. He's got his legs up in the air, right? He's doing a headstand. The vertex is still here, where the two legs meet. So every angle has a vertex. A point where the lines meet. Right? And let's put a blue dot there. There is the vertex where the lines meet. And there's the vertex there. And there's the vertex there. And there is the vertex there. And there's the vertex there. So I want you to draw some angles in your book and circle for each angle the vertex. And also I want to do the following. I want to write the letters A on one leg and B on the other. Right, this is going to be the last section of today's geometry lesson, and some more Latin. The word rectus in Latin. Let's write it out. Rectus means straight or upright. For example, here is Johnny, and he is standing straight up and down. There he is. Right, hands at his side. And he is standing erect. Right, you can see there's the rect and here's the rectus. He's standing erect, he's standing straight up and down. Right? We could, if we were nasty, get a long metal pole and we could stick it straight through him. Ouch. Right? Straight line. So you stand erect, straight, or straight up. Now, in English, this word rectus turned into the word richt, and then it became right. So that's how we got right from rectus. Now, in a right angle. In a right angle, we have a straight line like this. And the two angles on each side of the upright line, which I'm going to draw now, right? One moment, let's move this sideways like so, so I can fit this on. I'm going to draw an upright line that's coming off this bottom line here. Now what we have here is a very particular kind of angle. It's a very special kind of angle. It's the right angle, the correct one, especially if you are building a house. You want all your walls to be straight up and down from the ground. So in a right angle, these two angles, this one here, okay, we'll call it A, and this one here, we'll call it B. These two angles, A and B, are equal. They are the same, they're exactly the same, because this is a dividing line, and you can see they're the same. This is the same as that. So they are equal. We also say that they are perpendicular to each other. And to understand that, we have to do something a little bit different to show you what we mean by perpendicular. I'm going to turn this all upside down. Let's imagine that this is the ceiling and I'm hanging a string down, and it's got a weight attached to the end. Right? So it is hanging down from the ceiling. The word, what's a pendant that you hang around your neck? It means hanging. So something that's perpendant means it's hanging down very, very straight. So it is per, which means very much, all the way through. It's hanging all the way through, and it's perpendicular. It's hanging down very, very straight from this line here. So just like we just saw before, where you have a vertex, and it doesn't matter which way around your angle is, right? I'm going to do this without a ruler. Don't do it this way, right? There's your vertex, the top of the angle. There's your vertex, right? It doesn't matter whether it's up or down or sideways or any which way you like. The vertex, which means the top, right, can actually be at the bottom. It's where the two lines meet. Same with perpendicular. We get the meaning from the idea of a string hanging down from the ceiling. It's hanging down very, very much, straight down, right? But a perpendicular line can also be shooting out sideways, right? It can be going up this way. It doesn't really matter which way around we turn it, right? We still call it, it's perpendicular to the ceiling, or it's perpendicular to the floor, or it's perpendicular to the wall. Doesn't make any difference. So perpendicular. This line is perpendicular to that line. It's hanging down very, very straight. Right? Remember that here's Johnny, and he is wearing a pendant. There it is. He's wearing a pendant. Right? It's hanging around his neck. Right? There's his pendant. And the pendant is not perpendant, because it's going off at a side. However, if his pendant were to hang out this way, like that, very strong winds blowing, and there's his pendant hanging out to the side, then his pendant is perpendant, it's perpendicular. And we can check that's the case by putting our right angle onto it, and we'll see that it is indeed, right, hanging out at the right angle. Right, perpendicular. Now, the Romans had a special tool when they were building houses and palaces and all kinds of things. The Romans were very good at building things, and they wanted the walls of their buildings to hang straight. So they had a tool which was basically a string. There's your string with a piece of lead attached to the bottom, and this was called a perpendiculum. A perpendiculum. A perpendiculum was simply a string with a weight attached to it, and they'd hang it down. So here's Mr. Joe Architect. He's just built the palace for Nero, and here's the palace, and he's built a wall. It's very, very tall. Unfortunately, he built it in the mud, and the wall started to do that. So along comes the emperor's engineer, and he's going to pay for the work, and he takes his little bit of rope with his lead, and he hangs it down from the top of the wall, and he says, hey, that wall is not straight, because as you can see, this is hanging straight down, and in fact it keeps this pulled down right towards the center of the earth, and the wall is leaning. So Romans, they weren't modern architects, right? They were ancient architects, and they liked their walls and their buildings not to fall down. In fact, we have Roman buildings that are still standing up now after all this time. And one reason why they are still standing up is because the Romans were quite fussy about their walls being perpendicular. So a Roman wall would have been nice and perpendicular to the ground. This is a nice perpendicular wall. That would have made any Roman emperor very happy. Right? And that is no good. It's not the right angle. So this wall is not erect. Right? It's not erect. It's not the right angle. If you're a builder, you want your walls to be the right angle. This is not right. This is right. Right? You don't want your buildings to fall out. This is the wrong angle. So a right angle, here it is. This is the right angle here. Here's our right angle. There's one here. And there's another right angle here. Okay. The right angle is also perpendicular, right? Because we can check it that it's right by hanging down a perpendiculum in the real world. So this is a perpendicular wall. It's perpendicular, and it's also the right angle. And of course the Latin is rectus. And we'll see this rect word coming into play. We've already seen it here, erect. Right? So there are keywords for this perpendicular, erect, right, right, and rectus. And that's the end of this section of our introduction to geometry.